René obtained his PhD in 2011 at the University of Washington on atmospheric sciences, and he's a full professor at the Department of Geophysics at Universidad de Chile. His lines of work include climate change and vulnerability, and with an emphasis in South America. He's also a PI on the Water and Extreme Division of the Center for Climate and Resilience Research, CR2, and he will talk us about the consequences of climate change globally and specifically in Chile. Thank you, René.
Thank you, Carla. Thank you, Yara. Thank you all the organization for inviting me to this meeting. It was very nice to hear the Leonard talk that's provide this global background. And now I will focus a little bit on what happened in Chile with climate change, what has been going on over the last years and what is projected for the future. So incidentally, 20 years ago, I gave a talk in another seminar. It was in Valparaiso, this time was in person. And in fact, I wrote a paper after this talk with the climate of Northern Chile, mean state variability and trends. So if somebody wants to take a look of this, I can send this. This is in my webpage anyway. But part of the material for this presentation I took for this, that was 20 years ago. Something has changed, but we already knew 20 years ago, more or less, what was going on in our Earth. And the other paper that, of course, I will cite a lot here is one by Faustin about the impact of climate change. Of course, she will give a presentation, I suppose the next one after me. So I was fascinated with this map showing the astronomical observatories worldwide. And you see that obviously there is a lot of in Europe, in what we call the mid-latitudes, which is around 45 degrees, either north or south, right? But beyond this North America, part of North America and Europe, as you can see, most of the astronomical observatories are in what we call the subtropics, either in the northern hemisphere or in the southern hemisphere. And here's where you have the astronomical observatories in northern and central Chile. And there is a few of them also in Southern Africa, Australia, New Zealand, etc. So why we have these astronomical observatories in the subtropics? And this is just basic climatology. Remember that we envision the Earth, the atmosphere has to redistribute the energy. So you have a lot of energy reaching the equator or the low latitudes to form what we call the Hadley cells. And you have very strong rising motion, typically near the equator. This rising motion reached the tropopause around 15 kilometers above the surface and has to divert to both polar in both hemispheres and start to subside precisely in the subtropics. So where you have subsidence, you have higher pressure, generally an absence of cloudiness, very dry conditions, very stable conditions. So this is the reason why we have these many observatories in the subtropical areas. And when we look at climate change, we have to look particularly what happened in the subtropics. What is the impact of climate change in the subtropics will tell us something about what happened in the astronomy in general. Going back, as I said, I will focus most of my presentation here in northern and central Chile. So these subsidence reflect in this, what we call subtropical anticyclones. We have one in the Pacific, one in the Atlantic. And again, this is areas where the air is descending slowly, and that's create these very stable and dry conditions. And also create dry, relatively southerly winds here in the coast. Farther south, you get the mid-latitude storm track, and this is why you don't have observatories in southern Chile or much observatories in the mid-latitude in general. So this is your sweet spot for astronomical observations, right? Or traditionally, this has been the sweet spot. Everything will be kind of perfect for you guys, but there is a problem. You have a lot of moisture in the interior of the continent. And this is particularly true during the summer month. These images show different months. These are a climatology, and the shade that indicates where you have the more powerful cloudiness. And during winter, in July, the South America is actually quite dry, except in southern Chile. But as you move to the summer, and we are now right in the middle of the summer, you have a lot of convection, a lot of cloudiness over the Amazon basin that many times project over the central Andes and sometimes project into the Pacific. And that's bad news for you guys, right? Because it produces cloudiness over your astronomical observatories. In fact, sorry, this is a kind of technical image, but here one of the curve is the profile of temperature. Here, the axis, horizontal axis is temperature, vertical is the vertical level. Actually, this is pressure. So in winter, and the difference between these two curves give you an idea of the moisture content of the atmosphere. So in winter, actually you have very dry conditions all through the troposphere. This is a profile taken in Antofagasta. But this is, I don't know, well, actually this was 2 days ago or 3 days ago. You can see that it's quite moist, it's dry still in the kind of around 3,000 meters, but then it's generally moist because you have moisture air coming from the interior of the continent, crossing the central Andes, and eventually affecting the coast of northern and central Chile. This is a kind of, if you make a cross-section from the Amazon basin to the Atacama Desert, in winter, you have westerly winds going from the Pacific to the interior of the continent. So that's produced relative conditions over the Altiplano and the central Andes. But in summer, precisely now, you have these west-easterly winds coming from the interior of the continent to the Pacific, and that's bring moisture to the Altiplano, produce convective clouds over the Andes, and sometimes these clouds project over central and northern Chile. In fact, this is a very vivid image of what happened again a few days ago. By the end of December, you have a lot of convective storms here over the central Andes and the Altiplano, but that's generally, this is still quite dry, the coast of the northern Chile, but still part of the clouds project and the moisture come from the interior of the continent, and you can see here this kind of anticyclonic circulation bringing this moist air over northern Chile and eventually re-entering here around La Serena for this particular case. So this is our kind of basic stuff that we have to take in consideration when we talk about climate change. I haven't talked yet about this, but now I will move to this. And reflecting in what Leonard was saying, I am a climatologist, and I know that climate change is very important, but I understand that there are many other stressors for the world, right? You can have even astronomical stressors, or nobody wants to talk about this guy here. We also created our own stressors like nuclear bombs and stuff like that. But climate change is certainly quite important. It affects almost everything. It will stay with us in the short, mid, and long term. It's local and regional, but this is the good news. As Leonard said, first of all, we can project because we have models. We don't know how the futures will be. The future is open, but we can project. We have different scenarios. And on this basis, we can act. And act means adaptation in one hand, because the things is going on already, but also we can try to mitigate. The direction is very clear, but how far we will reach, of course, still depend on us. And this is the importance of this kind of meetings and conversations. So probably, you know, and Leonard already summarized the global evidence of climate change. You see, remember, we already have warmed 1 degree or 1.1. So when some kids ask me, we will reach the 1.5, this is terrible. Yes, it's terrible, but take in account that we already warmed 1.1 degrees. So the thing is that it didn't start yesterday. It started 1 century ago. And we have in this business of trying to adapt and mitigate at the same time. Now we have to mitigate very strongly, but we also have to adapt because the thing is going on. It's already with us. And obviously the sea level is increasing, the pH of this ocean is decreasing, etc. There is many global signs of this climate change. What happened in Chile, this is a very rapid summary of what is going on. Essentially, we have a decreased trend in precipitation, and we have something called the mega drought affecting central Chile, and even in southern Chile that is traditionally very humid also has experienced a dry condition over the last 40 or 50 years. So these are precipitation trends in winter and summer, and this is temperature. Temperature has increasing very rapidly, especially the maximum temperature, the one that you record around midday. But also there is a warming during nighttime. But again, the maximum trend is in the northern Chile, especially at high altitudes. Not much in the coast. The coast, it's trying, well, not so surprisingly, has been cooling. If you go to Antofagasta or Iquique, the water is cool, it's cold, and it has been a slight cooling over the last year, which is not incompatible with climate change. But the main signature, as you see, there is warming, except for this strip of land near the coast, warming almost everywhere of half a degree per decades, approximately, over the last 30 or 40 years. So what does mean for astronomical observation? Of course, this is what you want, right? Or this is at least what I imagine that you want. You want a nice observatory with clear skies, very nice. But sometimes you get clouds, you get winds, etc. So to make this a little bit more qualitatively, quantitatively, I make here a list of meteorological variables that can affect different kind of observing types. So cloud fraction is obvious, affect almost every kind of astronomical observations, but boundary layer turbulence, upper level winds affect, for instance, optical and near infrared. These both affect the seeing. Vapor, even if we cannot see the vapor, vapor is so important, especially when you make radio or near infrared astronomical observations. So there is many aspects that we have to look, meteorological variables, how they will change and how they will affect astronomical observations. And part of this has been done by some of my colleagues, but let me give you, if I have time, a few elements of what is going on precisely here in northern Chile. Once again, sorry that this is written in Spanish, but said the major source of uncertainty is how much CO2 will inject in the future. Remember, the future is still open. Of course, we can have, as Leonard was saying, different scenarios, and some of these are very negative and some of these are very optimistic. We don't know which one are the humanity taking. I hope that we're taking one of these one, the one with lower emissions and lower concentration. Then we take this concentration in the atmosphere, pass through the GCMs, the global circulation models, and obtain our projection for the future. And this is the one that we can examine and analyze and take our inference on what is the impact on astronomical observations. But always keep in mind that these are not forecasts. I am not forecasting that that will happen tomorrow. These are projections contingent to the level of CO2 and other greenhouse gases that we inject in the atmosphere. But anyway, for practical reasons, you tend to look the more negative scenario. I think that the most negative scenario, the so-called RCP 8.5, it will not happen, but it's kind of your top of the envelope, right? And if you want to adapt, you rather see the worst case scenario. This is why I am looking the RCP 8.5, not necessarily because this is what will happen, but give you an upper bound of what can be the consequences and the impacts. So if you move through this scenario, and again, this is a projection, you know, the world will become very warm, about 4 degrees or 5 degrees in average. Some areas will warm a lot, like 8 degrees in the northern hemisphere land masses. Again, the oceans warm less, but still everything warms, right? In different quantities because of the thermal inertia of the ocean and the land. Precipitation is much more complex in general. If you have more, in a warmer climate, you have more moisture and probably you will have more tropical precipitation. These are the green and blue colors here in the tropics. You will have more stronger and more intense storms, precipitating storms, the same in the latitudes in both hemispheres. But notice that here, for instance, in these subtropical areas, and again, remember that here is where we have our astronomical observatories. These are already dry areas that will become drier in the future. So the future is in some sense a continuation of what we are seeing now. We already have seen this drying trend in central Chile, and that's projected to continue in the last, well, these are projections for the end of the century, but they will continue gradually during the 21st century. Now, you guys have your observatories in northern Chile. It's already dry and it cannot be drier than that, right? But other aspects are very important for you. For instance, we will have in general stronger westerly winds in the upper troposphere. And again, this is important because they produce this halo phenomena. So this is not a good news, a particularly good news, because in general you have what we call a subtropical jet, and this jet will become stronger in the future. So expect stronger winds aloft blowing from the west. This is a cross section, but I think that this figure is clear enough, showing this stronger. These are not the winds, these are the difference between the future and the present climate, and it shows an acceleration of the westerly winds. There is already westerly winds in this area, and they will become stronger in the future, and that will eventually produce some problem with the optical observations here in northern Chile. And the same, by the way, the same happening in other subtropical latitudes. It's not only here in Chile, but the same happen over Southern Africa, Australia, North America, subtropical North America, etc. So this is something that we have to keep in mind. And as I said, stronger winds, more frequent halo, and this is not good news for you guys, I suppose. Now, if you have, let me go back just 1 second to this figure. Because you have a stronger westerly winds, maybe you have the hope that, remember that here you have the, and when you have a stronger winds blowing from the west, you tend to suppress any convection because you will have less moisture coming from the east to the central Andes. So that seems like a good news in the sense, at least for astronomical observations. This is kind of the future. This you can interpret like winter and summer, or you can interpret this like the current summer, and maybe in the future, the stronger winds will tend to produce dry conditions here over the Altiplano, and perhaps less of these clouds that come from the Altiplano to northern and central Chile. This is what we thought a few years ago. We have a couple of papers on the climate of the Altiplano, and we projected this again is future minus present under the A2 scenario, which is equivalent to RCP 8.5. And essentially what we project, because we have these stronger westerlies, we said, okay, so less moisture come from the Amazon, less precipitation. So this is just a very simple model based on the actual conditions. Stronger westerly tend to dry the central Andes. Now, the good thing of being a scientist is that you can be not believe yourself. And in fact, we have been revisiting what happened with the Altiplano. And in fact, this is again a very technical figure, but we realized that sometimes the moisture comes because of these east to west winds, but sometimes also come from the north. And in a more recent publication by Hans Segura and many others, we realized that over the last 2 decades, even if the winds has been increasing the westerlies, the precipitation has been increasing in the Altiplano, which was kind of puzzling for us. And we realized that moisture was being provided by a low-level jet that flows in the other side of the Andes and eventually reach the Altiplano. So unfortunately, the stronger westerlies aloft that will produce more halo, and we thought it will produce less precipitation over the Altiplano and less cloudiness over northern and central Chile. Maybe this will not be realized or not happen. And again, further research is needed, as we always said, right? So again, we are just beginning to understand what will happen with astronomical observations here in northern Chile. And finally, I don't know if I have 2 more minutes, Carla. Just let me know. I have or? Okay,
2 minutes.
Thank you. 2 minutes, excellent. Well, the other thing is, again, except for the coastal area, everything is warming, right? Most of the planet is warming. This is a figure that shows the warming trends over the last 40 years or so. Here is elevation from the surface, sea surface to the 10 kilometers. And again, except this is the zero line. So here is cooling and this is warming. So there is a very strong cooling below roughly 1 kilometer above the surface of the sea, but then there is a very strong warming. This is Calama, about 2.2 kilometers above the surface, and you can see that it's experienced a very strong warming. And the same happened with all these observatories at higher than 2 kilometers. And precisely in this work by Faustine, she made the point that these warmer environments produce a problem with the operation of the astronomical observatories, because you have to equilibrate, and probably Faustine will go in detail of this, you have to equilibrate at some moment the interior and the exterior temperature in the dome. So many things, we have done a lot of research on the impacts of climate change in South America, and particularly in Chile. Much of this, or part of this, has been done by the center where I work, the Center for Climate and Resilience Research. But we haven't targeted particularly the astronomical observations, and really happy to see these results. And I'm sure that we can work further, because we have some intuitions and some solid results, but we have to move further. And again, I am a climatologist, but I recognize that there are many other strengths. Many things are changing at the same time. And just this is my last slide, if you allow me. You have to work and push and try to reduce the emission of greenhouse gases. But also there is a trend in which every single phenomena is, and that was not the case of Leonard. Leonard made the case that maybe these storms in Germany were caused by climate change, because there is a trend in which everything is climate change. And actually this will work against us, because if everything is climate change, it's like I will drive my car, somebody will hit me and will say, sorry, this is climate change, I don't have insurance. There is people that is even using climate change to reduce liability. So be careful, we have to be very clear, we have to speak out, but we have to also, of course, we are scientists, we have to be very rigorous in how we express the information, And this is just a final reflection that I have as a climatologist. So saying that, I really appreciate your time and your invitation. I am in a very far from Santiago, in a very small town, precisely doing some outreach activities. And I hope that I can join for the discussion during this afternoon. Thank you very much, Carla, Yara, and the rest of the organizing committee.
Thank you, René. We have a little time for questions, but I will choose a couple. Priscilla asks you, which time of GCM are you using to get the westerly results?
We have GCMs, are these general climate circulations, and there is already around 25 or 30 available in the international community, and we share all of these. And we typically work with what we call the multimodal mean. Each model, well, all the models use the same physics, but they use different parameterization and different numerical schemes. And you know, the small details are important. So each model, you can think in each model like a unique or a special realization of the real world. So instead of taking one, we can take the 30. We can do the multimodal average that will give you the most robust signal of climate change. But also that's a good news because it's allow you to do this uncertainty analysis. I didn't go in detail on this, but most of my results are based on multimodal meaning.
Thank you. Robin asked you if you can give a few words about sea level rise and the effect for the most some of the Chilean cities that are at the coast.
Yes, of course. It's already, sea level has rise a few tens of millimeters. I don't remember exactly the name, and it will continue. This is a very robust measurement of the climate change because it basically integrate the thermal expansion, but also the melting of glaciers or land ice. And it will continue. I don't depend on the scenario. It's well documented. You also have to look at the regional geography. And it happened that in Chile, even though it will rise, it's not like Bangladesh, right? Where a small rise in sea level, it means that the area occupied by the sea is huge. Here, actually, when I talk with my colleagues, I don't work in physical oceanography, but actually the main threat is the sea level rise, but when combined with marejadas, how you said that? Well, when the waves are very big because of the wind effect. So it's a concern, but not by itself, but rather because it provides a higher baseline over which this sea storm can superimpose. Again, if you send me an email, there is plenty of literature addressing this point. They will not reach Paranal or La Silla or whatever, so don't worry. But if you live too close to the line or to the coastline, of course, these marejadas, I don't remember the name in English, it's an issue. It's already an issue.
Sure. Thank you, René. And I invite you to answer a question that is for you specifically from Roger in the Q&A part of the webinar, and also to all the attendees to frame your questions in the Q&A.